My name is Jennifer Steele, and I'm calling my YouTube channel right now. I'm calling it Uncommon Sense Analytics, and I call it Uncommon Sense because this is stuff, analytic skills that you haven't been taught in school, but perhaps should have been. So, what we're learning today are we're learning to simulate data, to create our own fake data sets in Stata. We're going to use Stata for this task. And we're going to simulate data from an interesting psychology article from many years ago. And it's called Marital Processes Predictive of Later Dissolution. So it's a study that was really well done. It's kind of a famous study about the differences between how people communicate if they're happily married or they're not happily married. And so we're going to look at the data from this study because we don't have the real data, but we're going to see what would happen if we tried to create data that looked like this data, and what inferences can we draw when we can better visualize the data in a way that it's not visualized in the article. Then we're going to look at how do large language models, ChatGPT, CoPilot, and Claude, how do they do if we ask them to do this task for us? If we ask them to write this code if we ask artificial intelligence to write this code for us, let's see how they do compared to how we do writing the code. So we're going to cover a lot of content in this, and I'll probably break this up into small subset videos. So let me screen share to show you the article that we're trying to simulate. And it looks like this. It's an old article by John Gottman, who is kind of a guru of helping couples communicate better in marriages and relationships. So this is some of his early research. And what he did is he had 73, he started out with 79 couples, but when he did follow-up data, he only had 73 couples. And he recruited them from outreach to folks in newspaper ads in Bloomington, Indiana in the 1980s. And then he tracked them for 4 years to see who stayed married and who got divorced. But we're not going to get that far. We're going to look at just how do we create the data on how old the people are in the study and how happy they are in their marriages as a function of whether they communicate well or badly when they're observed in a laboratory. So he ended up with couples where the husband's average age was 31.8 years old, so about 32 years old. The wife's average age was a bit younger, 29 years old. And the standard deviations of those things are important because standard deviation, as I cover in my classes, is the average distance of each person from the average. And so that's going to be relevant to what we're talking about in this article and how to interpret the data. So the men were more varied in their ages than the women. Their average distance from the average was about 10 years. So some were close to 32, but some were quite a bit younger and quite a bit older. And the average distance from the average wife's age of 29 was only about 7 years, 6.8 years. So the women's ages were a little bit more compressed, but still some variability. And they had been married an average of 5 years. And so we're going to try to simulate that. But we're also going to simulate what they observed in how well they communicated. And the way they defined communication in this article is couples that had good emotional regulation when they had to talk about a difficult marital problem for 15 minutes. This was carefully observed and coded and recoded by other people on their research team without knowing ahead of time anything else about the couples, just how they communicated. So they coded a lot of variables. And they said the couples that kind of had more positive than negative during the 15 minutes were considered regulated, emotionally regulated. The couples where the negative continued to increasingly outweigh the positive comments and behaviors during the 15 minutes were considered not regulated. They were, so they had an interesting way of just defining people's communication, which they break down into greater detail. But what's important for our purposes is that they wound up with 42 couples they considered well-regulated in how they communicated, and 31 couples that were not well-regulated. And what they found in the end, they found many things, but one of the interesting things that they found was that at the start of the study in 1983, the regulated couple's marital satisfaction was 104. They don't even say what the bottom and top scores are, but we're going to simulate that. And they did tell us that the standard deviation of these numbers is about 22 points. So the regulated couples had a happiness of about 104, and the unregulated people in unregulated couples had a happiness of about 90. So that's a difference of about 14 points. And they tell us up above that that the average regulation of that the average marital satisfaction, here it is, that the average marital satisfaction is about 96.8 for males and then about 98.56 for females. So just under 100 is the average marital satisfaction. And so we can see that regulated couples are a little bit above that at about 104, and unregulated couples are quite a bit below that at about 90. So that's an interesting finding, and that's what we're also going to try to simulate. So what we're going to do, and what we're eventually going to ask ChatGPT to do for us, is generate a random data set from nothing, just out of nothing. We want 146 people in our data set because there's 73 couples. So each couple in this study has a male and a female. So it's 73 couples times 2 people, 146 observations. We're going to set the seed at 1992 so that if you follow my steps online, you should get the same results that I get if we all set the seed at 1992. Each observation, each person is half of a couple. We want each couple to have one husband and one wife. There should be an ID for couple. So each couple should have its own ID number. And there should be a variable for wife that's coded 1 or 0, because they're in this data set, they're only going to be either a wife or a husband. Please create an age variable for each person. We're going to ask ChatGPT to do this. The mean age of wives is going to be 29 years old with a standard deviation of 6.8. The mean age of husbands is going to be 31.8, as I've already showed you. But no husband or wife is going to be less than 18, because these people had to be able to consent to be in a study, and they have to be married. So you can get married at less than 18, but we're going to presume that these are all adults. So here's how we're going to try to get at instead of getting random variables for males and females' ages, which can lead us with people like a 60-year-old man married to a 20-year-old woman, which is not that likely in this data set of 73 couples. So we want to impose some correlation between males and females' ages, and we're going to tell ChatGPT to do that. So we're going to say the average gap between the husband's and wife's age should be about 2.8 years, which it was in the data set. But instead of putting in the standard deviation for males, we're going to put in a gap variable with that has a standard deviation of just under 1 year. And that's going to cause the males and females to have ages that are a little bit closer together, so we don't get things that are super crazy. And we're also going to have to bound this so that no wife is less than 18 years old. So we're going to tell ChatGPT to write the code that would produce this. Then we're going to have it create a binary variable that is a 1-0 dichotomous variable. And we're going to call it reg for whether they had regulated communication or not. Reg is going to be 1 if they are a regulated couple. There's going to be randomly chosen 42 couples with that. And randomly chosen 31 of the rest of the couples are going to be coded 0 for not regulated in our fake data set. And we're going to create a variable called marital satisfaction that exists for each person, not each couple, because each human has a level of satisfaction in the marriage. So that variable, as we've said before, the standard deviation is 22.43. The average should be, now here's how we did this. We're going to take our decision to, here's how I think we should go about this. We're going to take the gap between males and females in marital satisfaction, which is 1.76. We're going to split that between regulated and non-regulated couples because we don't know how many of each are in each group. So we're going to center men's and women's satisfaction around their group mean for regulation. So we want the average to be 104.96 for wives if they're in a regulated relationship, 103.19 for husbands. And then if they're not in a regulated relationship, we're going to ask ChatGPT to make us to make the marital satisfaction have an average of 90 for wives and 88.77 for husbands. So then we're going to ask ChatGPT, and we'll do this first on our own in Stata, to create a horizontal box plot of marital satisfaction with different boxes for wives and husbands in regulated and non-regulated marriages. Then we can see how big do these distributions look when we see them visually. How big are the gaps when we see them visually? So that is what we're going for. Now, I want to show you first how we do this in Stata. So that means that we're going to review some concepts. This is kind of an intermediate skill because we're creating simulated data from scratch. We're not using an existing data set. And that means that we have to tell Stata how we want the data to be distributed. So we're going to create so I've got a blank Stata window here. You see that when I click the data browser, there's no data. The data set is empty. There's no data in the data sheet. Okay. There are no variables on the right. There are no commands that we've run on the left. We're going to create a data set from scratch. So the way that we're going to do this is we're going to set the seed at 1992, which just allows us to make sure that every time we randomly generate our data, we get the same random numbers. So we'll start there. We'll highlight that line and run it. Okay, so it ran without an error. So now we're going to say we want 146 observations. We're setting the number of observations at 146. So that tells Stata that this is how many people are in this is how many rows are in our data set. So it did that for us, but they're still blank. So now we're going to create the identifier for couples. And we're going to do that by generating a variable called couple. And the way that we want this to look is couple number one should be in rows 1 and 2. It should be couple one. And then it's going to be husband, wife, or wife, husband. And then couple 2 is going to be couple 2, couple 2, couple 3, couple 3. So we want the same two numbers for rows 1 and 2. So couple 1 will be in rows 1 and 2. Couple 2 will be in rows 3 and 4. Couple 3 will be in rows 5 and 6. And that's how we want to generate the data. So to do that, we need to give each couple a number. And we're going to do that by telling it that we want to take the n, which is the number of the row, which here is row 1, here is row 2, here is row 3. We take the row number, divide it by 2, and round up. Ceil, C-E-I-L, means divide it by 2 and round up. So we take underscore n, which means the row number, divide by 2 and round up. So when we do that, when I press play and run that command, now I have my variable called couple, and it's coded 1 for couple 1, 2 for couple 2, and this should go all the way down to couple 73, which it does. So that worked great. So now we're going to create a variable called wife, and wife is going to be coded 1 if the row is an odd number. Wife is going to be coded 2 or 0 if the row number is even. So the way that we achieve that is if n divided by 2 does not equal the rounded up integer of n divided by 2, then we know that it's an odd number. If it does equal the rounded up integer, if n over 2 equals the ceiling, the rounded up integer of n over 2, then we know that it's even, and we want to call that a husband, which means wife equals 0. So we're going to run those two lines. We're going to highlight both lines and run them. And it worked great because now the first row of couple 1 is a wife. The second row of couple 1 is a husband. First row of couple 2 is a wife. Second row is a husband. And the reason we don't need a husband variable is because this is defined as dichotomous, and there's no category of person that is not either a wife nor a husband. Okay, in this data set. So now we're going to create the ages. And this is a little tricky because we can't have, if we just do a normal distribution, if we create a normal distribution, we might get some ages that are less than that. What that will do is it will create a bell-shaped curve of ages where the mean is 29 for women. And but it could go above that, like up to 2 or 3 standard deviations above that or below that, which means you can wind up with some very young ages where people would not be married. So we need to truncate this normal distribution, and that's a little tricky. This is an advanced command. We're going to install a command called gentrun. It's generate truncated variable. And what that does, gentrun, is we're going to create a variable called age women, or age W for wife norm, which is going to be the normalized age for the wife. And we're going to have the command here to truncate that at the left value of negative 1.61. Now, how did I come up with negative 1.61? The answer is I had to figure out, I knew that I wanted her to have a mean of 29 years old, standard deviation of 6.8. So I took that mean, I subtracted the lower bound, which is 18 years old. So 29 minus 18 is 11. And then I divided that by the standard deviation. So that would be, it comes out to 1.61, but I want it to be negative because a normal distribution that's mean 0, standard deviation 1 has a negative tail on the left. And so I create that normal distribution with this command called gentrun age W norm. That's going to be the variable age W norm. And it's going to be truncated at the left at negative 1.61 instead of going further out to the left. So when I run that command, let's see what happens. When I run just that command, I get no error message, and I have this new variable now called age W norm. And sure enough, if I create a histogram of age W norm, it should look like a normal distribution, roughly a normal distribution. It's not going to be perfectly normal. Here it is. It's not perfectly normal because it's only 146 people, and also because we truncated it. So instead of coming all the way out to the negative bell curve, it's cut off on the left at 1.61 negative. And nevertheless, I believe it still has a mean of 0, standard deviation of 1. Let's just test that. Summarize age W norm, and has a mean of a little bit higher than 0 because we truncated it, and a little bit less of a standard deviation of 1 because we truncated it, but still pretty close. So now we're going to convert that to what we want the age distribution to really look like, which means that we take that normal distribution with mean 0, standard deviation 1, we multiply it by the standard deviation we want for women, which is 6.8, and we add 29, which is the mean. And what that will do is it will create a new variable called age W, age for wives. And that should look like the age distribution that we want. And we can test that by running another histogram. And let's just run that command. And oh, age 1 already defined. Oh, I ran it twice. That's why. So let's go ahead and make our histogram. And so, yes, now it's the same distribution, but it's been multiplied by 6.8, so that now it has a standard deviation of 6.8, and now it has a mean of 29. And so this is what the distribution of women's ages, wives' ages in the study roughly look like. We're simulating, it's not the real data, but we're trying to imitate what we think the data look like. So, and we would do this for many types of things where we want to replicate studies, where we want to test how well our models run on different types of data. There's lots of reasons you would simulate or create your own data from scratch. So yeah, so now we have these women ranging from 18 to about their late 40s. Okay. So now with men, again, I don't want the issue where we have men's and women's ages that are highly discordant, which was what was happening when I just created men's ages the same way that I created women's. So instead, what made sense to me was to have a normal distribution for the gap between males and between husbands and wives. So we're going to keep the gap as it was in the study of 2.8 years on average between men and women. But we're going to keep that gap with a lower standard deviation. I played around with this and I'm going to use 0.9. So when I do that, now I get a variable called, we're going to summarize, age gap, just to see what that looks like. It looks like it has a mean of 2.78, standard deviation close to what we asked for, 0.82. The reason it's not exactly what we asked for is because these are random numbers. They're always going to be different. They'll be the same for you if you use the same seed, but they're random numbers, so they're not necessarily going to perfectly fit the specs that we gave because they're random. So we see that the gap ranges from less than a year, people very close in age, to about 5 years. Okay. So now we're going to create the husband's age by adding the wife's age plus the gap. So we're going to generate age H equals age W plus age gap. And now we have men's age, the husband's age. And so we can look at how are these things correlated. And they should be fairly well correlated because of how we design the data. So when I create the scatter plot of two-way scatter of ages of wives against ages of husbands, wives are going to be on the y-axis, husbands are on the x-axis. And yeah, they're pretty tightly correlated because we created the data to be correlated. We created the gap to have a normal distribution with not a very big standard deviation. And then we just added the gap to the wife's age. So they're not perfectly correlated. You have some men that are a little bit, their wives are like a 40-year-old man. This 40-year-old man his wife is about 37. And this one, his wife is about 35. So there's some variation, but not a huge amount of variation. And we did that on purpose. Okay, so we can also sum those distributions and we can see that it looks pretty much how we want it to look. The average age is 29 for women, 32 for men. Standard deviation for both is about 6.5, 6.6, which is a little less than was in the real study for males, but we'll go with it. And nobody's younger than 18 years old. So that worked. Now we are going to, now we're going to create a new age variable because right now we've got ages of wives as one column, ages as husbands, as age of husbands as another column. We're going to create a new column that is overall age, and it's going to have the husband's age if they're a husband, it's going to have the wife's age if they're a wife, which means now you have every individual person's age once we do that. And we do that by just saying, I want to generate a new variable called age. I want it to be the age of the wife if wife equals 1. And I want it to replace it with age of the husband, age H, if wife equals 0. So that's a 2-step process that we run those 2 lines. And when we do that, sure enough, we have a new variable called age. And if you're a wife in couple 1, you're 37. If you're a husband in couple 1, oh, this one's a little bit younger. This husband is younger than the wife. If you're a husband in couple 1, you're 30. coming down to couple 10, if you're a wife, you are 46. If you're the husband, oh, this is another one where the husband is younger. You're 33. Let's find one that has a more typical distribution. Yeah, couple 2. Okay. So couple 2, the wife is 26 and the husband is 30. So there's a gap where the husband's about almost 4 years older. We're about 4 years older than the wife. And couple 15, the husband's only 1 year, not even 1 year older than the wife. They're very close in age. So you can see that our procedure worked. Okay. So now we're going to stop there and we're going to see if ChatGPT can do what we just did. And to do that, we're going to copy my instructions, just the first part of my instructions that pertain to age. And we're going to put that into ChatGPT and see if it can write that code for us. Okay, so it's recounting what we want it to do. It's making sure that it understands that we want 73 couples, 146 individuals. We want a binary variable of wife equals 1 if it's a wife, 0 if it's husband. Okay, generate, and it's doing a pretty good job so far, but let me see. So it's telling us to, oh, it already made a mistake. It told us to set observations at 73 and not at 146, even though we said we wanted 146 individuals, 146 observations. So it already got that wrong in the first line. It did correctly set the seed. It did generate a couple because it's doing each line as a couple. What it's doing is one line, one row is a couple instead of one row as a person. So in that case, generate couple equals n works. Age of wife, our normal 29 with 6.8 is okay. And it's not doing a fancy way of truncating the normal distribution. It's just going to say, if the wife's age is less than 18, replace it with 18. So that's kind of a shortcut. And it's not quite as mathematically precise because what it's going to do is it's going to drive up the mean even more, most likely. So it also is saying that it's generating the age gap correctly as a normal distribution. It is correctly calculating the husband's age. And it's doing the same thing of just chopping off, replacing the husband's age as 18 if he ends up being younger than that. Oh, this is how it's going to do, getting us back to an individual data set. It's going to do a reshape. So it's going to then create the wife's age variable, the husband's age variable. It's going to reshape the data so that the identifier for the couple will be one variable and the role, wife or husband, will be another variable. So it's reshaping from wide to long, which is if that works, this code so far might work. So then we're going to generate age as wife. Oh, condition of wife's age if wife equals 1, husband's age if wife equals 0. And then we're going to get rid of the variables that we don't need. Now we should have couples 1 through 17, or couples 1 through 70, couples 1 through 73, wives 1 or 0, age greater than or equal 18, 146 observations total. And okay, I'm gonna run their code and see what happens. So let's try that. Because this code could work, even though they started off with 43 observations, they went about it differently because they did a reshape. So let's copy that. Let's bring it over here to Stata and let's create a new do file. So in our do file window, I just did a blank tab, and we're going to call this Chat GPT attempt at Gottman. Okay. So I'm copying and pasting this straight from ChatGPT with everything as is, and we're going to call this save as Gottman simulation, Gottman ChatGPT. ChatGPT. Okay, we're going to run it. I'm just going to, should I run it all at once, or should I run it step by step? Okay, let's clear the, oh, we don't even have to clear the data. That's our first command. Let's run the first 3 commands. Okay, when I run ChatGPT's first 3 commands, I now have a new data set with 73 rows, totally blank. And I'm going to create the couples and replace it with wife's age is 18 if the wife's age is less than that. So that replaced 3 wives that were previously less than that. So now if I do a histogram of age wife, let's see what it looks like. Yeah, not bad. Not bad. It looks reasonably like a normal distribution. Okay, now we're going to create the age gap and then the husband's age. We're going to do this, and no changes were made in the husband's age. We didn't need to replace any anybody that was less than 18 because that's normal because we're adding to the wife's age, and the wife's age is already not less than 18. So this replace if age husband is less than 18 really is redundant in this case. Then we're going to reshape the data because right now we have data where every row is a couple and there's a variable for wife and a variable for husband, but we want a different row for each person because we're going to have other like marital satisfaction later. So we're going to do this reshape. So generates wife age equals age wife, and that's going to be a new variable. And that's because I think we want the word wife to come first instead of last. Same thing for husband. That's going to be a new variable. That's exactly the same as this other variable. Age husband, husband age are the same. We're going to keep the newly named variables. Okay. Now we're going to reshape with couple is going to be our ID variable. And role, wife or husband, is going to be a new variable when we do the reshape. So when we do the reshape, these 73 rows are going to become 146. So this is a powerful command, reshape. When we run that, it ran correctly, or did it? No. I'm still seeing, oh, I think I'm getting errors. Let's see what it says. Oh, it does not. The reshape command did not run. Okay. So reshape long is good. I couple makes sense. J role makes sense. I couple, J role. Looked for existing variables named A and B, but could not find any. So we want reshape long. We need the variables that we wanted to reshape. And so maybe we need to modify this to say, well, we did say we want to reshape wife age and husband age. Reshape long, wife age, husband age. Let's get rid of the J. Let's try it again. Existing variable, J, the new variable. We want J to be role. Reshape long, wife age, husband age. Oh, it's not working. So, yeah. Huh. What we want is for wife and husband to become a 1-0 variable. And then age, this is also order. Okay, so this will take me a little time to troubleshoot. And so we're going to talk about what we've learned so far. In a future video, I will do the task where we create people's satisfaction with their marital satisfaction as a function of whether the couples were regulated in their communication or not. But what we've seen in this video is how to generate variables from scratch. What happens when you ask Stata to do that same thing? It's doing better than it was doing a few years ago when ChatGPT first came out, but it's still making mistakes that we then have to troubleshoot. Not always a bad thing. Sometimes it's worth it to do the troubleshooting, except that in this case, we had already written the code and we already have code that we know works. And we're getting buggy code with ChatGPT. For the sake of it, before we end the video, let's just try what would happen if we put it in Claude. So let's go to CoPilot. Okay. Let's just try, let me do a screen share. Because CoPilot was written as part of GitHub originally, which is a coding tool. So let's see what happens when we put the same request, not into ChatGPT, but, oh wait, that's the instructions. I want the first paragraph of my request. Okay. So let me put in the first paragraph of my request and see what happens when we ask CoPilot. Oh, it says something went wrong. Okay. We can try again. And it worked. Okay. So once again, it sets the seed correctly. It correctly sets the observations as 146. It generates couple just the way that I did with the ceiling. It creates the wife indicator and generate wife and mod underscore n, which is the number, comma 2. So it's doing something similar to what we did with if it's an even or odd number. Generate random age for wives, normal distribution, truncated at, let's copy this. Let's paste this into our do file and put it over here. And we're going to call this CoPilot. Okay, so now we can see it better. So it is going to generate the random variable for the wife's age. It is going to do a similar thing to what ChatGPT did, which is it's going to take the larger of wife's age, or 18. So it's going to just lop off anything less than 18. And then it will do the age gap. Again, making sure that the age gap is not ever less than, is truncated at 0, because we don't want it to be less than 18, age to be less than 18. It's going to add the husband's and wife's age, and it is then going to assign the appropriate age variable based on whether it's the husband or the wife. And it has a cool little math trick for doing that, which is the wife variable times the wife's age plus 1 minus wife, which is the husband variable. Basically, this will become positive if it's the husband times the husband's age. So that's a cool trick. It will then do a final cleanup, which we don't necessarily need it to do, and display the first 10 observations. So let's clear Stata and run that code and see what happens. So let's, oh wait, we don't have to clear it because it's already in code. So I'm highlighting all of the CoPilot code. I'm running all of it. I'm looking at the data. And I now have data for a 26-year-old wife, a 42-year-old husband for couple one, a 25-year-old wife, and a 38-year-old husband for couple two. So even though we set the same seed, because we didn't do the random number generation exactly the same, we came up with slightly different numbers. Nevertheless, it looks like if we summarize age by, let's see, that's age by life, that's mean SD. So we see that wives have an average age of almost 29. Husbands are a little bit older than 32. Standard deviation is a little bit bigger for husbands, which is what we would want from the original data. Nobody's younger than 18 years old, and they're tapping out at about 49. And let's see what the scatter plot, two-way scatter of age. We can't do that because we've deleted those variables. So in order to fix that, we have to run everything again except the part where we deleted them. So that's easy to fix. We just ran everything except line 65 again. And now we can do a scatter plot, two-way scatter of age wife and age husband. And yeah, they're positively correlated, not that different from what we created with our own attempts. So far, the winner between CoPilot, which is a Microsoft product that started with GitHub, and the winner between CoPilot and ChatGPT is clearly CoPilot. And so there we have it, creating data from scratch, testing how can AI help us do this or support us in doing this, what works better, what doesn't work, and thinking about the principles of what do these variables mean along the way. So thank you for listening, and feel free to put any questions in the comments, and I'll see you next time.